Windows PowerShell is a task automation and configuration management framework from Microsoft, consisting of a command line shell and associated scripting language built on the .NET framework. PowerShell provides full access to COM and WMI, enabling administrators to perform administrative tasks on both local and remote Windows systems, as well as WS-Management and CIM, enabling management of remote Linux systems and network devices. In PowerShell, administrative tasks are generally performed by cmdlets, which are specialized .NET classes implementing a particular operation. Sets of cmdlets may be combined into scripts, executables, or by instantiating regular .NET classes. These work by accessing data in different data stores, like the file system or registry, which are made available to the PowerShell runtime via Windows PowerShell providers. Windows PowerShell also provides a hosting API with which the Windows PowerShell runtime can be embedded inside other applications. These applications can then use Windows PowerShell functionality to implement certain operations, including those exposed via the graphical interface. This capability has been used by Microsoft Exchange Server 2007 to expose its management functionality as PowerShell cmdlets and providers and implement the graphical management tools as PowerShell hosts which invoke the necessary cmdlets. Other Microsoft applications including Microsoft SQL Server 2008 also expose their management interface via PowerShell cmdlets. With PowerShell, graphical interface-based management applications on Windows are layered on top of Windows PowerShell. A PowerShell scripting interface for Windows products is mandated by Microsoft's Common Engineering Criteria. Windows PowerShell includes its own extensive, console-based help, similar to man pages and Unix shells, via the Get Help cmdlet and updatable with fresh content using the Update Help cmdlet and web-based content via the online switch to Get Help. Background: every released version of Microsoft DOS and Microsoft Windows for personal computers has included a command line interface tool. These are command.com and cmdlets. The shell is a command line interpreter that supports a few basic commands. For other purposes, a separate console application must be invoked from the shell. The shell also includes a scripting language, which can be used to automate various tasks. However, the shell cannot be used to automate all facets of GUI functionality, in part because command line equivalents of operations exposed via the graphical interface are limited, and the scripting language is elementary and does not allow the creation of complex scripts. In Windows Server 2003, the situation was improved, but scripting support was still considered unsatisfactory. Microsoft attempted to address some of these shortcomings by introducing the Windows Script Host in 1998 with Windows 98, and its command line-based host, xScriptx. It integrates with the ActiveScript engine and allows scripts to be written in compatible languages, such as script and VBScript, leveraging the APIs exposed by applications via COM. However, it too has its own deficiencies. It is not integrated with the shell, its documentation is not very accessible, and it quickly gained a reputation as a system vulnerability vector after several high-profile computer viruses exploited weaknesses in its security provisions. Different versions of Windows provided various special-purpose command line interpreters with their own command sets. None of them were integrated with the command shell. Nor were they interoperable. By 2002 Microsoft had started to develop a new approach to command line management, including a shell called Monad. The shell and the ideas behind it were published in August 2002 in a white paper entitled Monad Manifesto. Monad was to be a new extensible command shell with a fresh design that would be capable of automating a full range of core administrative tasks. Microsoft first showed off Monad at the Professional Development Conference in Los Angeles in September 2003. A private beta program began a few months later which eventually led to a public beta program. Microsoft published the first Monad public beta release on June 17, 2005, Beta 2 on September 11, 2005, and Beta 3 on January 10, 2006. Not much later, on April 25, 2006, Microsoft formally announced that Monad had been renamed Windows PowerShell, positioning it as a significant part of their management technology offerings. Release Candidate 1 of PowerShell was released at the same time. A significant aspect of both the name change and the RC was that this was now a component of Windows, and not an add-on product. Release Candidate 2 of PowerShell version 1 was released on September 26, 2006 with final release to the web on November 14, 2006 and announced at Tech Barcelona. PowerShell for earlier versions of Windows was released on January 30, 2007. PowerShell V 2.0 development began before PowerShell V 1.0 shipped. During the development, Microsoft shipped 3 Community Technology Preview. Microsoft made these releases available to the public. The last CTP release of Windows PowerShell V 2.0 was made available in December 2008. PowerShell V 2.0 was completed and released to manufacturing in August 2009, as an integral part of Windows 7 and Windows Server 2008-02. Versions of PowerShell for Windows XP, Windows Server 2003, Windows Vista and Windows Server 2008 were released in October 2009 and are available for download for both 32-bit and 64-bit platforms. Design: Windows PowerShell can execute 4 kinds of named commands, cmdlets, which are .NET programs designed to interact with PowerShell, PowerShell scripts, PowerShell functions, standalone executable programs. If a command is a standalone executable program, PowerShell X launches it in a separate process. If it is a cmdlet, it is executed in the PowerShell process. PowerShell provides an interactive command line interface, wherein the commands can be entered and their output displayed. The user interface, based on the Win32 console, offers customizable tab completion but lacks syntax highlighting. PowerShell enables the creation of aliases for cmdlets, which are textually translated by PowerShell into invocations of the original commands. PowerShell supports both named and positional parameters for commands. In executing a cmdlet, the job of binding the argument value to the parameter is done by PowerShell itself, but for external executables, arguments are passed by the external executable independently of PowerShell interpretation. The PowerShell extended type system is based on the .NET type system, but with extended semantics. For example, it enables the creation of different views of objects by exposing only a subset of the data fields, properties, and methods, as well as specifying custom formatting and sorting behavior. These views are mapped to the original object using XML-based configuration files. Cmdlets are specialized commands in the PowerShell environment that implement specific functions. These are the native commands in the PowerShell stack. Cmdlets follow a verb-noun naming pattern, such as getChildItem, helping to make them self-descriptive. Cmdlets output their results as objects, or collections thereof, and can optionally receive input in that form, making them suitable for use as recipients in a pipeline. But whereas PowerShell allows arrays and other collections of objects to be written to the pipeline, cmdlets always process objects individually. For collections of objects, PowerShell invokes the cmdlet on each object in the collection, in sequence. Cmdlets are specialized .NET classes, which the PowerShell runtime instantiates and invokes when they are run. Cmdlets derive either from cmdlet or from PS-cmdlet, the latter being used when the cmdlet needs to interact with the PowerShell runtime. These base classes specify certain methods, begin processing, process record and end processing, which the cmdlet's implementation overrides to provide the functionality. Whenever a cmdlet is run, these methods are invoked by PowerShell in sequence, with process record being called if it receives pipeline input. If a collection of objects is piped, the method is invoked for each object in the collection. The class implementing the cmdlet must have one .NET attribute, cmdlet attribute, which specifies the verb and the noun that make up the name of the cmdlet. Common verbs are provided as an enum. If a cmdlet receives either pipeline input or command line parameter input, there must be a corresponding property in the class, with a mutator implementation. PowerShell invokes the mutator with the parameter value or pipeline input, which is saved by the mutator implementation in class variables. These values are then referred to by the methods which implement the functionality. Properties that map to command line parameters are marked by parameter attribute and are set before the call to begin processing. Those which map to pipeline input are also flanked by parameter attribute, but with a value from pipeline attribute parameter set. The implementation of these cmdlet classes can refer to any .NET API and may be in any .NET language. In addition, PowerShell makes certain APIs available, such as WriteObject, which is used to access PowerShell's specific functionality, such as writing resultant objects to the pipeline. CMDLets can use .NET Data Access APIs directly or use the PowerShell infrastructure of PowerShell providers, which make data stores addressable using unique paths. Data stores are exposed using drive letters, and hierarchies within them, addressed as directories. Windows PowerShell ships with providers for the file system, registry, the certificate store, as well as the namespaces for command aliases, variables, and functions. Windows PowerShell also includes various CMDLets for managing various Windows systems, including the file system, or using Windows management instrumentation to control Windows components. Other applications can register CMDLets with PowerShell, thus allowing it to manage them, and, if they enclose any data store, they can add specific providers, as well. In PowerShell V2, a more portable version of CMDLets called modules have been added. The PowerShell V2 release notes state, modules allow script developers and administrators to partition and organize their Windows PowerShell code in self-contained, reusable units. Code from a module executes in its own self-contained context and does not affect the state outside of the module. Modules also enable you to define a restricted runspace environment by using a script. Pipeline. PowerShell implements the concept of a pipeline, which enables the output of one cmdlet to be piped as input to another cmdlet. For example, the output of the get process cmdlet could be piped to the sort object cmdlet, and then to the where object to filter any process that has less than 1 MB of paged memory, and then finally to the select object cmdlet to select just the first 10. As with Unix pipelines, PowerShell pipelines are used to compose complex commands, using the operator to connect stages. However, the PowerShell pipeline differs from the Unix analog in that structured .NET objects, rather than text, are passed from one stage to the next. Using objects eliminates the need to serialize data, or to extract it by explicitly parsing text output. An object can also encapsulate certain functions that work on the contained data, which become available to the recipient command for use. For the last cmdlet in a pipeline, PowerShell automatically pipes its output object to the out default cmdlet, which transforms the objects into a stream of format objects and then renders those to the screen. Because all PowerShell objects are .NET objects, they share a toString method, which retrieves the text representation of the data in an object. In addition, PowerShell allows formatting definitions to be specified, so the text representation of objects can be customized by choosing which data elements to display, and in what manner. However, in order to maintain backwards compatibility, if an external executable is used in a pipeline, it receives a text stream representing the object, instead of directly integrating with the PowerShell type system. Scripting. Windows PowerShell includes a dynamically typed scripting language which can implement complex operations using CMDLets imperatively. The scripting language supports variables, functions, branching, loops, structured error exception handling and closures lambda expressions, as well as integration with .NET. Variables in PowerShell scripts have names that start with $. They can be assigned any value, including the output of CMDLets. Strings can be enclosed either in single quotes or in double quotes. When using double quotes, variables will be expanded even if they are inside the quotation marks. Enclosing the path to a file in braces preceded by a $sign creates a reference to the contents of the file. If it is used as an L value, anything assigned to it will be written to the file. When used as a value, the contents of the file will be read. If an object is assigned, it is serialized before being stored. Object members can be accessed using notation, as in C syntax. PowerShell provides special variables, such as $args, which is an array of all the command line arguments passed to a function from the command line, and $, which refers to the current object in the pipeline. PowerShell also provides arrays and associative arrays. The PowerShell scripting language also evaluates arithmetic expressions entered on the command line immediately, and it parses common abbreviations, such as GB, MB, and KB. Using the function keyword, PowerShell provides for the creation of functions, the following general form. The defined function invoke in either of the following forms. PowerShell supports named parameters, positional parameters, switch parameters and dynamic parameters. PowerShell allows any .NET methods to be called by providing their namespaces enclosed in brackets, and then using a pair of colons to indicate the static method. For example, System console writeline, PowerShell. Objects are created using the new object cmdlets. Calling methods of .NET objects is accomplished by using the regular notation. PowerShell scripting language accepts strings, both raw and escaped. A string enclosed between single quotation marks is a raw string while a string enclosed between double quotation marks is an escaped string. PowerShell treats straight and curly quotes as equivalent. For error handling, PowerShell provides a .NET-based exception handling mechanism. In case of errors, objects containing information about the error are thrown, which are caught using the trap keyword. However, the action or error is configurable. In case of an error, PowerShell can be configured to silently resume execution, without trapping the exception. Scripts written using PowerShell can be made to persist across sessions in a PS1 file. Later either the entire script or individual functions in the script can be used. Scripts and functions are used analogously with cmdlets, in that they can be used as commands in pipelines, and parameters can be bound to them. Pipeline objects can be passed between functions, scripts, and cmdlets seamlessly. However, script execution is disabled by default and must be enabled explicitly. PowerShell scripts can be signed to verify their integrity, and are subject to code access security. The PowerShell scripting language supports binary prefix notation similar to the scientific notation supported by many programming languages in the C family. Hosting. Another use of PowerShell is being embedded in a management application, which uses the PowerShell runtime to implement the management functionality. For this, PowerShell provides a managed hosting API. Via the APIs, the application can instantiate a runspace, which runs in the application's process and is exposed as a runspace object. The state of the runspace is encased in a session state object. When the runspace is created, the Windows PowerShell runtime initializes the instantiation, including initializing the providers and enumerating the cmdlets, and updates the session state object accordingly. The runspace then must be opened for either synchronous processing or asynchronous processing. After that it can be used to execute commands. To execute a command, a pipeline must be created and associated with the runspace. The pipeline object is then populated with the cmdlets that make up the pipeline. For sequential operations, a pipeline object is created for each statement and nested inside another pipeline object. When a pipeline is created, Windows PowerShell invokes the pipeline processor, which resolves the cmdlets into their respective assemblies and adds a reference to them to the pipeline, and associates them with input pipe, output pipe and error output pipe objects, to represent the connection with the pipeline. The types are verified and parameters bound using reflection. Once the pipeline is set up, the host calls the invoke method to run the commands, or its asynchronous equivalent, invoke async. If the pipeline has the right host cmdlet at the end of the pipeline, it writes the result onto the console screen. If not, the results are handed over to the host, which might either apply further processing or display it itself. The hosting APIs are used by Microsoft Exchange Server 2007 to provide its management GUI. Each operation exposed in the GUI is mapped to a sequence of PowerShell commands. The host creates the pipeline and executes them. In fact, the interactive PowerShell console itself is a PowerShell host, which interprets the scripts entered at command line and creates the necessary pipeline objects and invokes them. Versions. Initially using the codename Monad, PowerShell was first shown publicly at the Professional Developers Conference in September 2003. All major releases are still supported, and each major release has featured backwards compatibility preceding versions. PowerShell 1.0. PowerShell 1.0 was released in 2006 for Windows XP SP2, Windows Server 2003 and Windows Vista. It is an optional component of Windows Server 2008. PowerShell 2.0. PowerShell 2.0 is integrated with Windows 7 and Windows Server 2008-02 and is released for Windows XP with Service Pack 3, Windows Server 2003 with Service Pack 2, and Windows Vista with Service Pack 1. PowerShell V2 includes changes to the scripting language and hosting API, in addition to including more than 240 new cmdlets. New features of PowerShell 2.0 include PowerShell remoting. Using WS-Management, PowerShell 2.0 allows scripts and cmdlets to be invoked on a remote machine or a large set of remote machines. Background jobs, also called a PSJOB, it allows a command sequence or pipeline to be invoked asynchronously. Jobs can be run on the local machine or on multiple remote machines. An interactive cmdlet in a PSJOB blocks the execution of the job until user input is provided. Transactions enable cmdlet and developers can perform transactional operations. PowerShell 2.0 includes transaction cmdlets for starting, committing, and rolling back a transaction as well as features to manage and direct the transaction to the participating cmdlet and provider operations. The PowerShell registry provider supports transactions. Script cmdlets, these are cmdlets written using the PowerShell scripting language. Note, the preferred name for script cmdlets is now Advanced Functions. Steppable pipelines, this allows the user to control when the begin processing, process record and end processing functions of a cmdlet are called. Modules, this allows script developers and administrators to organize and partition PowerShell scripts in self-contained, reusable units. Code from a module executes in its own self-contained context and does not affect the state outside of the module. Modules can define a restricted run space environment by using a script. They have a persistent state as well as public and private members. Data language, a domain-specific subset of the PowerShell scripting language that allows data definitions to be decoupled from the scripts and allows localized string resources to be imported into the script at runtime. Script debugging, it allows breakpoints to be set in a PowerShell script or function. Breakpoints can be set on lines, line and columns, commands and read or write access of variables. It includes a set of cmdlets to control the breakpoints via script. Eventing, this feature allows listening, forwarding, and acting on management and system events. Eventing allows PowerShell hosts to be notified about state changes to their managed entities. It also enables PowerShell scripts to subscribe to object events, VS events, and WMI events and process them synchronously and asynchronously. Windows PowerShell Integrated Scripting Environment, PowerShell 2.0 includes a GUI-based PowerShell host that provides integrated debugger, syntax highlighting, tab completion and up to 8 PowerShell Unicode-enabled consoles and a tabbed UI, as well as the ability to run only the selected parts in a script. Network file transfer, native support for prioritized, throttled, and asynchronous transfer of files between machines using the background intelligent transfer service. New cmdlets, including out grid view, which displays tabular data in the WPF grid view object. New operators, split, join, and spatting operators. Exception handling with try-catch. Finally, unlike other .NET languages, This allows multiple exception types for a single catch block. Nestable here strings. PowerShell here strings have been improved and can now nest block comments. PowerShell 2.0 supports block comments using and as delimiters. New APIs. The new APIs range from handing more control over the PowerShell parser and runtime to the host, to creating and managing collection of run spaces, as well as the ability to create restricted run spaces which only allow a configured subset of PowerShell to be invoked. The new APIs also support participation in a Windows PowerShell managed transaction. PowerShell 3.0. PowerShell 3.0 is integrated with Windows 8 and with Windows Server 2012. Microsoft has also made PowerShell 3.0 available for Windows 7 with Service Pack 1, for Windows Server 2008 with Service Pack 1, and for Windows Server 2008-02 with Service Pack 1. PowerShell 3.0 is part of a larger package, Windows Management Framework 3.0, which also contains the WinRM service to support remoting. Microsoft made several community technology preview releases of WMF3. An early community technology preview 2 version of Windows Management Framework 3.0 was released on December 2, 2011. Since then, updated versions have been shipped in the Windows 8 and Server 2012 beta and release candidate versions. New features in PowerShell 3.0 include scheduled jobs. Jobs can be scheduled to run on a preset time and date. Session connectivity. Sessions can be disconnected and reconnected. Remote sessions have become more tolerant of temporary network failures. Improved code writing, code completion and snippets are added. PowerShell ISE allows users to use dialog boxes to fill in parameters for PowerShell cmdlets. Delegation support. Administrative tasks can be delegated to users who do not have permissions for that type of task, without granting them perpetual additional permissions. Help update. Help documentations can be updated via update help command. New commands, new modules and cmdlets automate printer management previously performed via WMI. PowerShell 4.0. PowerShell 4.0 is integrated with Windows 8.1 and with Windows Server 2012-02. Microsoft has also made PowerShell 4.0 available for Windows 7 SP1, Windows Server 2008-02 SP1 and Windows Server 2012. New features in PowerShell 4.0 include desired state configuration, declarative language extensions and tools that enable the deployment and management of configuration data for systems using the DMTF management standards and WS-Management protocol. New default execution policy. On Windows servers, the default execution policy is now remote signed. Save help. Help can now be saved for modules that are installed on remote computers. Enhanced debugging. The debugger now supports debugging workflows, remote script execution and preserving debugging sessions across PowerShell session reconnections. Pipeline variable switch, a new ubiquitous parameter to expose the current pipeline object as a variable for programming purposes. Network diagnostics to manage physical and Hyper-V's virtualized network switches. PowerShell 5.0. An initial public preview of PowerShell 5.0 was made available with Windows Management Framework 5.0 on April 3, 2014. Key features include 1. Get PowerShell scriptlets to support Chocolate's repository-based package management and extending support for switch management to Layer 2 network switches. Comparison of cmdlets with similar commands. The following table contains a selection of the cmdlets that ship with PowerShell, noting similar commands in other well-known command line interpreters. Many of these similar commands come out of the box defined as aliases within PowerShell, making it easy for people familiar with other common shells to start working. Notes. ClearHost is implemented as a predefined PowerShell function. AB available in Windows NT 4, Windows 98 Resource Kit, Windows 2000 Support Tools, AB available in Windows XP Professional Edition and later, also used in Unix to send or process any signal. The terminate signal is merely the default. File extensions, PS1 Windows PowerShell shell script, PSD1 a Euro Windows PowerShell data file, PSM1 a Euro Windows PowerShell module file, PS1 XML a Euro Windows PowerShell format and type definitions, CLI XML, Windows PowerShell serialized data, PSC1 a Euro Windows PowerShell console file, PSSC, Windows PowerShell session configuration file. Application support, snap-ins and hosts, alternative implementation. A project named PASH has been an open-source and cross-platform re-implementation of PowerShell via the Mono framework. PASH was created by Igor Muchnik, written in C and was released under the GNU General Public License. PASH development stalled in 2008, but was restarted in 2012. See also, Common Information Model, Comparison of Command Shells, Comparison of Programming Languages, Web-based Enterprise Management, Windows Script Host, References. Further reading, Holmes, Lee. Windows PowerShell Quick Reference. ISBN A0-596-52813-2. Holmes, Lee. Windows PowerShell Cookbook. ISBN A0-596-52849-3. Retrieved September 19, 2010. Johnson, Willis. Scripting SQL Management Objects in Windows PowerShell. ISBN A978-0-470-27935-9. Retrieved September 19, 2010. Don Jones, Jeffrey Hicks. Windows PowerShell 2.0 TFM. ISBN A978-0-9821314-2-8. Kopkinski, Tyson. Windows PowerShell Unleashed. ISBN A0-672-32953-0. Kumaravel, Arul. John White, Michael Nason Lee, Scott Happel, Gauri Zai, Krishna Sivu Tukurai. Professional Windows PowerShell Programming, Snap-ins, cmdlets, Hosts and Providers. ISBN A0-470-17393-9. Retrieved September 19, 2010. Oakley, Andy. Monad. ISBN A0-596-10009-4. Rottenberg, Hal. Managing VMware Infrastructure with Windows PowerShell, TFM. ISBN A0-9821314-0-2. Retrieved September 19, 2010. Tyson Kopkinski, Pete Handley, Marco Shaw. Windows PowerShell Unleashed. ISBN A978-0-672-32988-3. Watt, Andrew. Professional Windows PowerShell. ISBN A0-471-94693-1. Retrieved September 19, 2010. Wilson, ed. Microsoft Windows PowerShell Step by Step. ISBN A0-7356-2395-3. Fink, Doug. Windows PowerShell for Developers. ISBN A1-4493-2270-0. Retrieved July 1, 2012. External links, Microsoft's Windows PowerShell webpage, download Windows PowerShell 4.0, Windows and Windows Server Automation with Windows PowerShell, Windows PowerShell Team Blog, Windows PowerShell Community Forum, Windows PowerShell Quick Reference Materials.